So basically, what is glycolysis? Now, if we want to break this word down, it's glucose. Lysis is breaking down. Lysis is breaking down. So it's breaking down of glucose. Now, why do we need to break down glucose? Well, because our body needs to breathe, okay? And not just through our lungs, through oxygen and whatever. This is at the cellular level, at the level of the cells, you know? So what we need is the glucose, and the cell cannot just use glucose as a form of energy. It needs to break it down into smaller, let's say, units for it to convert it to energy. Okay, this is just a simple explanation of what glycolysis is. It's actually the first step of cellular respiration, as I just said. Now, if I just go through what I highlighted right here, all of the enzymes are in the cytosol. So in the cell, the enzymes of glycolysis are in the cytosol. The cytosol, يعني the cytoplasm, okay? And it provides ATP. ATP is the form of energy that we need, adenosine triphosphate. Now, if we go directly to the glycolysis, inshallah, I'm going to make it easy for you guys. Now, getting into our work right here, this is where I'm going to explain the exact mechanism of glycolysis. So if we look right here, so this is actually the cellular membrane that we learned about in our first years of medicine. This is the lipid bilayer, as we learned before. And as we all know, glucose is actually a water-soluble molecule. It's a monosaccharide, meaning single sugar. Meaning single sugar. Saccharide means sugar. There's disaccharides, polysaccharides, whatever. So glucose is a water-soluble monosaccharide, and it can go into the cell. It doesn't need a lot of help, but here, using this GLUT transporter, meaning GLUT as in glucose, and transporter, it helps it go into the cell, and it goes into the cell, right? So actually, this is not our topic right now, but GLUT has a lot of types. So there's GLUT2, GLUT4, whatever. Now let's just say GLUT. So glucose enters the cell, right? And then, since GLUT is a bidirectional transporter, that means that when glucose comes in, it can just go out, right? But what the cell does to retain the glucose inside, it picks up this enzyme called hexokinase, right? So, what does it mean? Kinase is a type of enzyme that adds a phosphate group, or PO43 minus, that adds a phosphate group into a molecule, right? So what it does is that hexokinase comes and it adds a phosphate to our 6-carbon glucose. This glucose, we add a 6-carbon phosphate to it, a phosphate group to the 6-carbon glucose. Okay, so where does this hexokinase get its phosphate from? Well, it dephosphorylates an ATP, adenosine triphosphate. It takes a phosphate group from this ATP, and the ATP becomes ADP. Adenosine triphosphate becomes adenosine diphosphate. Okay? So the first step is to retain the glucose inside the cell. Now the next step is involving an enzyme called an isomerase. Now, what are isomers? So if we recall what isomers are, so basically isomers are molecules with the same molecular formula, such as C4H10, which is butane, and isobutane, right? But the main difference between them is how they are arranged, like the carbon and the hydrogens, how they are arranged within this. It might be linear, it might be chained. That's the only difference, okay? So glucose and fructose have the same molecular formula, C6H12O6, right? Best, the only difference is that they are different in their arrangement, okay? So the cell converts this glucose 6-phosphate into this fructose 6-phosphate, which is the sugar right now in this position. Now, another enzyme comes in called phosphofructokinase 1. So phospho from phosphate, fructo from fructose. Kinase, what does kinase mean? We said that before. It means adding a phosphate. And 1 is on the first position. So actually, hexokinase added the phosphate on the 6th carbon. Now this one's going to add the phosphate on the 1st carbon. So we end up with fructose 1,6-bisphosphate. Now, what's the difference between biphosphate and bisphosphate? Well, actually, if we look right here, biphosphate is when the phosphate is added to two carbons that are beside each other, right? Now, bisphosphate is added to carbons that have a distance between them. You know what I mean? Like they're not close to each other. So it's called bisphosphate because there's a phosphate on carbon number 1 and carbon number 6, right? And it's fructose, of course, from right here. Now, so where did this one get the phosphate from? Of course, from ATP, right? So ATP becomes ADP, and we take PO4, 3 minus, and we add it to the first position. Okay. Now, if you're going to ask me a question that's like, why do we even need to add another P to the sugar that we have? Well, that makes it easier to break it, right? So if we add another phosphate, it becomes easier to break. And that's exactly what happens right now. Another enzyme called aldolase breaks this fructose, this big word, into 2 compounds, or 2 molecules, The first one is called dihydroxyacetone phosphate, and this one is called glyceraldehyde, I think, 3-phosphate, okay? So, this molecule is broken down into these 2 smaller molecules, and these can, okay, so this means it's a reversible reaction, right? So G3P can become DHAP, and DHAP can become G3P. But when I use these arrows, this means G3P cannot go back to this one. It cannot go back. But when I use these, it means they can go back towards each other, right? And it's called a triose because, well, we're dealing with 3 carbon molecules, okay? It's easy. Now, to continue. Now, starting with G3P, continuing actually. Now, G3P is right here. And a coenzyme comes called NAD. So what NAD actually stands for, it's called nicotine amide adenine dinucleotide. I know the name is crazy. Now, you don't have to memorize it. I don't even remember all the time. So basically, NAD comes and steals 2 hydrogens from G3P. Well, actually, each NAD takes 1 hydrogen. There's 2 NADs. When I put times 2, it means there's 2 of this molecule. Okay, so NAD comes and takes 1 hydrogen from G3P, and another NAD comes and takes hydrogen from G3P, and they become NADH, right? NAD actually is a coenzyme that is involved in redox reactions. And what are redox reactions? They are reactions that involve taking and giving electrons, okay, or protons, hydrogen, yani, okay? So NAD now just took a hydrogen, right? So that's exactly its job in redox reactions. Now, G3P becomes called 1,3-bisphosphoglycerate, right? 1,3 meaning we have phosphate on the 1st and 3rd position, right? And it's bis because they're not near each other. They're far away. Now, 1,3-bisphosphoglycerate becomes 3PG. Why is that? Because if you remember from the first phase of this glycolysis, we took phosphate from ATP. Now it's time to return it to ATP, you know? Because this is the first law of chemistry. Energy is neither created nor destroyed, it's only transferred, right? So we actually took it here, now we're giving it back, right? So ADP, it takes a phosphate from bisphosphoglycerate and it becomes 3PG. So it took the one in the first position. And we still have this. So it's called what? 3PG, right? The enzyme involved in this is called phosphoglycerate kinase. Why? Because it's phosphoglycerate and a kinase takes phosphate and adds it, right? Remember, times 2. Now, what the cell does, I don't really know why, it just switches the position. So the phosphate on the third group right here, it switches it to the second group. So it's called 2PG by an enzyme called phosphoglycerate mutase. Mutase is just a class of an isomerase, okay? There's no difference. Now, 2PG becomes phosphoenol pyruvate. But what does enol mean? Or enolase is an enzyme that makes a molecule an elon. Enol. Enol. Okay, so if we go back to basic chemistry, we know that there are alkanes, alkenes, and alkynes. This is an alkene, or this is an alkene, right? And this is alcohol, the functional group of alcohol, right? So if you add the functional group of an alkene and an alcohol, ene plus ol, you get an enol. So an alkene plus an alcohol is an enol right here. Okay? This is just an example. This is an alkyl group, of course, and this is the enol right here. So what happens is that an enolase converts this 2-phosphoglycerate into a phosphoenol pyruvate, right? And now what happens? We also took ATP in I think this is the third step of glycolysis right here. Now we're gonna need to give it back again. So ATP comes back because we owe it money. And now we take this away, right? The phosphate, we give it back to ATP by a pyruvate kinase, of course. Pyruvate from the name of the molecule right here. And kinase is just, as I explained before, it takes phosphate and adds it, right? So we took the phosphate and now we end up with pyruvate, which is the end of the glycolysis pathway, but the start of another pathway called the citric acid